Hi everyone. Let's just start this at 11:12 to make sure everyone who wants to turn in can tune in. So we're gonna start in 3 minutes. Um, Hi Allison. How are you doing? I already. What was that? Gallagher? Is that you, Gallagher? Can you please change your name? Hey Ethan. Hey Alton. Esther. Rosie. Hey Siddharth. Hey Aaron. What's up, dude? Happy 11/11, everybody. Make a wish if you believe in that sort of thing. Hey, Dennis. Hey, Jonathan. Nice of you to tune in. All right, it's 11:12. Before I begin, let me just send. Hey, Meg. Let me just send a reminder. The examining magnetic field assignment based on the YouTube video that I sent out. So far, I'm missing 17 of them out of 68 total students. All right, so I have 51 turned in, 17 TBD. It's now late. Please get it in ASAP. All right, remind your friends that they should be turning it in. Okay. All right, let's get started. So for number one, my current's going this way, and it's a positive current. So I'm going to use my right hand, and all that means is put my thumb this way, and now I can. I will be granting some leniency this time because I know for some of you this is like the first time you're using Google Classroom. But on the assignment that's called examining magnetic field, there should be an option to turn it in. Right? This isn't like through a comment. It's actually just actually turning in. There's like a little button that says submit assignment. All right? But don't worry about that now. Let's go over this right now. So if you watch the video, you'll notice that the compasses will always point in like a circle, right? And the direction of that circle depends on the direction of the current. And in this case, A will be pointing out of the page, and B will be pointing into the page. Okay? It's that simple, right? Because the field's going this way, right? Around. It's going, I want to say, this way, and it goes behind the wire. So at that point, that's where B is. At that point, that's where A is, right? We're just going into the page. Okay? All right. Now if we move on to number two, again, this current is moving out of the page, so that tells me to put my thumb this way, right? It's gonna come this way, and I'm just looking at the curl. So my field is just gonna be all like in these like circles, right? Which means at point D, my field points straight up. At point C, it points straight sideways. At point B, it's 335 to 325 to 300, 315, 315 degrees this way, right? And 315 degrees this way. The only difference between A and B is that the field at A is a little weaker than B because it's further from the wire, but they're in the same direction, right? This is literally the compass demo in a nutshell, right? Instead of 6 compasses all around, I just have 4. And all of those compi should be pointing in this direction. Now, if the current was going into the page, bum, 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 then it would be backwards, right? So I would go thumbs down, and I'm curling this way. So my field would go this way, this way, this way, and this way, right? But fortunately, that's not the case because I already told you the current's going out of the page. So I know the field points in this direction, right? And also, if I had a point here, it would be pointing this direction if I had like a point E or something. And I hope you see that this is identical to number 1. Like if I place a sheet of paper right here, it'll come out of the page and into the page, right? And that's what we're looking at here, all right? I hope that makes a little bit more sense, okay? I'm sorry for the technical difficulties. Just bear with me. Sometimes you can refresh and it'll be better. If it's still like really not that good, the recorded version will be in full 1080p. So that's something you could also try, right? But if you want to ask questions, like that's what the advantage of tuning in live is for, right? Okay. Number 3, the current's going this way, right? So I'm just going to use my right-hand rule, and it goes this way. So that basically tells me everywhere. So at B and C, that's pointing into the page. And at A and D, it's pointing out of the page. Everywhere outside is pointing out of the page, right? You can imagine like this wire, and if that wire was curved and it went like in a circle, then it's like, and the circle's going here, like everywhere inside the circle is like point E, and everywhere outside the circle is like point D. Okay. And finally, for number 4, this is a solenoid, but that's just a bunch of these stacked together. So you just really have to like look at which direction it's going in, and it's going this way, right? So the current's going that way. And so that means I can tell if it's going this way, behind the front wire, it'll point up, and in front of the front wire, it'll point down. And for this back wire where the current's going this way, behind it, the current's pointing down, and in front of it, it's pointing up, okay? Which means the zone inside here, all my field always points up. And outside, it'll always point down, right? So now I can have my little bell pepper shape, right? If that's what that's really getting at. Which means at point A and point B, the field points down. Point C, if it is outside the solenoid, it's just like A and B, and it'll point down. And if point C is inside the solenoid, it'll point up, right? That's how the field is pointing inside the solenoid. Set. I am anticipating next week it's going to be a little bit more than this, right? So I just wanted to gradually ramp you up a little bit to what you should be expecting, okay? At what point does the field curve? Elon, what we like to say, so when we say like, if this is a North Pole and this is a South Pole, and I draw my field lines like this, and so that they are curved, the field vectors at any point are actually still straight, right? Because if I say, hey, what's the field there? You just take the tangent line. What's the field there? You take the tangent line. Yeah, because basically, like, if you put a compass there, your compass really getting at is these field lines tell you where the compass will point, and it's going to be tangent to the curve. So to answer your question, the field never curves, right? The field lines, like what we're using, I mean, I guess they do curve, and they curve all the time because, like I went over on Tuesday's lecture, field lines are never going to be like electric field lines, right? So if I have like a positive charge, that field line goes forever and ever and ever and ever. But it goes in here, it returns, and then it basically forms a loop that way, right, inside the solenoid. But I thought you said field lines don't curve. I mean, not curves, but the field vector at every point is actually straight, right? It's just tangent to these curves, right? It's like what the compass would do. All right. Are there, does this work? Hello. So are there any other questions? Because if not, I want to wish you a really happy weekend. And I guess something we also can do is just to go over the anticipated schedule for next week. All right, so I'll do that right now. Okay, so this week was our little pilot week. I'm anticipating for next week to look something like this, and I will send this out in an email as well. Okay, and Lon is asking another question. If a point is above the solenoid, how do we know if it's pointing up, down, or horizontal? You don't. Without knowing like the very specific geometry of the solenoid, which is why I didn't give you a problem there. If it's straight above the center, it'll be pointing up. Like right here, it'll always be pointing up if you're right there on the solenoid, or down, right? Depending on like if it's here, it's up. If it's here, it's up. Any point outside it, it's going to be a little tilted, right? And way outside, it's going to be pointing down. And like when it tilts from this, like how do I know if it's horizontal? Yeah, you don't. Without actually just measuring it. That's like asking that's not the exact same question as like, oh, so how do I know if I'm in this zone? How do I know? There are formulas with which you can like actually calculate it out, but it's really not worth your time. Okay. I have one question about 1. How come B isn't part of the field? Well, okay, I just misdrew the circle. It should be going like here. Okay. All right. So our schedule for here, Monday, we'll just have a live stream lecture, just like last week, number 1. And I will also pass out the worksheet. Okay. Tuesday, you will have to submit an image of your work for that worksheet by Tuesday morning. All right. I'm checking for completeness, not correctness. And if there's a question you don't understand, all you have to do is kind of write down, I don't understand this. And also, you must write a question down. That way, before we start reviewing the answers, I can kind of identify like, hey, okay? Then Wednesday and Thursday, it'll repeat, right? So we'll have the second stream of the lecture. I'll pass out the second worksheet or second assignment. Then you will submit the assignment by Thursday morning. And then we will review solutions, right? And then Friday, it'll be kind of a more fun stream, right? It'll be office hours. I can share some music I've been listening to, show you my favorite recipes that I've managed to perfect in my boredom stuck here, right? And that's just going to be the schedule, like moving forward, okay? Also, later this weekend, I'll be submitting a survey, so you guys can provide feedback. You can please let me know what's working about the stream, what you like about the stream, what you don't like about it. Wants to submit their opinion. Okay, cool. With that, I want to leave. I want to wish you a really nice, restful weekend, and get ready for your third lecture on Monday. Right? Get pumped. Yeah, that's it. I hope y'all are doing well. Okay. Keep it real.